Sir, borehole.
Okay. Uh, boreholes. Boreholes are basically, it could be two different things. One is, it could you can create a bore under the soil, or you can create the bore under the ice sheets. Now the question is, if I create it, what we can understand? If you go to downward from the top of the surface, the temperature has sharply increases. This is the normal understanding, and the rate of the increases of the temperature is basically 30 degrees centigrade for per kilometer. So if you go to the further downward, your temperature will sharply, it will be increasing, and this is a sharp increasing trend, where you can get the idea about the time periods, and about also you can understand about the temperature variations. Now the question is, how can I know the past climate? The question is, it should be very smooth and sharp, but suddenly you can see some changes. That means your temperature variations in a large basis. So in a particular time period, it has been changed. So if you set up those temperature pattern in a graph, and you found that in a particular time period in somewhere, so maybe for example from here, you get some information, but in down at the right side, couple of 100 years or 50 years after, you get suddenly some different information from there. So if you just see the depositions, and you get the information that their temperature has been different on the basis of effect, cause and effect. For example, most of the cases we know there is something happening, and then you get the effect. But here what we do, we go for some inverse way to find out the temperature. So the temperature differences from one place to another place during the course of time, we wanted to try to understand why the temperature has been disrupted, because the next line from that particular point, it was similar as before. So the interruption from one point to another, that means maybe the after 50 years there has been an interruption, or 20 years there has been an interruptions. So those information can be segregated and plotted in the graph, and then we can understand the differences between the temperature of a particular time. So boreholes basically give you the idea of the underground temperature with the edges. Because if you go to downward of the ice cores, you can get different sets of edge limits. Because when ice has been, glaciers has been created, it is created layer after layer, and you can easily find out the edges of that particular ice from carbon isotopes. So you can understand the time period, and then you can understand the changes of the temperature, and then you reconstruct your past climates with the inverse process. Is it okay?
Yes, sir.
Someone asked, how can oxygen isotope give the information about the temperature? Fine, good question. As I described, atomic weight of the oxygen is 16 normally, but there are another type of oxygen that's isotope is shows the atomic weight of 18. So isotope 18 is less amount in the ocean or in any water substances, and also isotope 16 is large and more. So there is a ratio. Normally there is a ratio of oxygen 18 divided by oxygen 16. There is a ratio. But what do you have when the temperature increases or decreases, when they evaporates? With the increasing of the temperature, the firstly the oxygen 16, their evaporation is much more rather than the oxygen 18. Okay, so they react much more than the oxygen 18. Okay, so what amount of the oxygen 16 has been evaporated, and then again they come back to a snow deposition that can be measured from a ice cores or from a sediments. And these sediments, they shows a ratio between oxygen 18 and 16. Now, if you have a chronological data set that if the oxygen 18 and oxygen 16 ratio is something, and then after a certain period you can get again another sets of ratio, then you can determine what was the temperature before in two conditions. And then you can also analyze the temperature graphs between 2 points. Sorry. Uh, Shubhra also asked, sir, is it possible to determine the age of the trees through their tree rings? Yes, obvious. Why not? Trees, as you see also the first YouTube video that that person said this is a 64 years rings, 64-year trees. If you cannot find out the ages, how can you also find out the differences of the temperature in different years? So tree rings give you the idea, obviously the ages first. First of all, they showed the ages, and from their growth, we can analyze the temperature and precipitation. Any other question? Okay, so if you do not have any other question, I should go forward because I have running of time because I need another 2 classes in the next week to complete it. Before that, I should complete some of them. So can you understand these things, past climates, how we can reconstruct past climates? Is it okay?
Yes, sir.
Okay, so in your exam, it might become that uh, how we can construct past climates, or what are the different proxy indicators and how can we use them to construct past climates, like this type of question will come. Okay. Now we are going to see the possible causes of the climate change. So the climate change, when you say climate change, this is on special topics and very important topics also. But when you say how the climate has been changes, that time the question is little bit different. We can say, why does the climate vary or change? That time you have many answers. So we do confirm that climate has been changing, but these changes could be a natural cycle. This cycle means come again and again. So it could be at many different, based on different anthropogenic causes by the human beings, or it could be a feedback from different other type of activities. So when we go for the causes, we can differentiate between between different sets of sources. One source is anthropogenic drivers, but there are many other ways we can see this variation, which is very natural, and we although that have very much more impact on our life, but we are not normally, we do not discuss that because this is the natural phenomena and we don't have any hand to control it. So we do only only think about the anthropogenic drivers rather than the other things. So first of all, we do discuss about the internal mechanisms by which we can see the climate varies time to time. But again, I should say, again, keep in your mind, this is something which shows the energy balance between two different environmental components. One is ocean, another is maybe the land surface. One is ocean, or another is atmosphere. So interaction between atmosphere and land surface and interaction between atmosphere and ocean surface, they determined that sometimes the energy balance in relatively different ways, so that we can see some of the events throughout the world. And basically these are internal mechanisms, and we should not very worried about that because it has been changing time to time. Yes, we do have also very good attention on them because they have influence on our life, but we have nothing to do that, because that is based on the internal mechanism to changing their energy balance. So if I can discuss them, you can understand very nicely. So those internal mechanisms can be described in the 4 different titles in different areas of this world. One is North Atlantic Oscillation, which is in the Atlantic Ocean north part. One is Southern Oscillation or El Nino, which is governed in the Pacific Ocean. One is Sahel drought or the Atlantic multi-decadal oscillation. That is also in Atlantic oscillation, but that has been also impacted from the drought condition of the Sahel. Sahel is a desert. And also there is another one, Pacific decadal oscillation. So both these two are a decadal oscillation, and both these two are patterns for a couple of years. And very interestingly, they have positive and negative phases that come one after another. So that means they have been balanced to one another. So it's okay, but we need to also understand that things. Just to see, this is North Atlantic oscillation. You can see normally the nature of the wind is the flow from high pressure to low pressure. This is our Atlantic Ocean, and this is our North America, and this is Europe. Okay, and maybe this is France, and this is UK. Okay, and this is Atlantic Ocean. So the process is the wind that should be go from high pressure to low pressure. So what happened during couple of times, a couple of years after, North Atlantic surface temperature is quite high. And we know this high temperature that is very light, and they move very fast, and they are mixed up with very high amount of the water vapor and temperature. Now the westerlies, they move from this direction to that direction. Okay, with the Coriolis effect, they also move from this way. So when they are very hot and humid, and these westerlies move in that direction, all the way along they reach to UK and other countries with huge amount of the heat, and also moisture. So that makes the country hot and warm, and that time they get much of the precipitation. This is one phase. This is, we call, say, positive phase. On the negative phase, when the temperature is the surface temperature of the Atlantic is not so high, and that time the wind movement also very slow, and they cannot go all the way along to this way. They move further downward, straightforward, and with low amount of the heat, not too much. So that particular time the westerlies is weak, but the easterlies, which is coming from this way, which is coming from the north block, that time it is very cold, because they are dry and cold. And that year, in that particular couple of years, the UK and other countries of that time, this they feel very cold and sometimes snowing. So this is North Atlantic oscillation. So to make you a good understanding, let's see a video about North Atlantic oscillation.
The NAO, or North Atlantic Oscillation, is an important tool for forecasting long-term weather patterns across the UK, particularly in winter. Now, the NAO itself is actually quite simple to measure. It's just the difference in pressure between 2 points over a period of time across the North Atlantic. Sometimes that pressure difference is high, and at other times the difference isn't so strong. And it's this variation that is the oscillation, the NAO. Now, this pressure pattern is the reason why we normally get westerly winds across the UK. When we've got low pressure here and higher pressure here, it means the winds tend to come in from the Atlantic. Now, the difference in pressure dictates how strong those winds are. And when we have a positive NAO, the difference in pressure is large. There's a strong gradient, and those westerly winds are that much stronger. So they're bringing in mild air from the Atlantic, and that leads in winter months to mild and wet conditions, and potentially stormy winters too. When the NAO is negative, that pressure difference isn't so noticeable. It's weaker. The westerly winds are weaker, and when that happens, it gives a greater chance for easterly winds to come in across the UK. Easterly winds in winter bring cold air, and so when the NAO is negative, there's a greater chance of a snowier winter. Now, it's important to point out that the NAO just gives an indication of the most likely pressure setup over a period of time. Any pressure chart on a given day would be different. But what the NAO does give are strong clues as to the types of winter that we can get. Recent studies have actually shown that our computer models are very good at predicting the NAO, and that's why it is one of the key features in the Met Office's winter forecast.
So you can understand that in recent times that the model of the different models, they also shows the how the NAO will be changed during course of time, maybe in the next year and after the next year. And as it is, it shows, you see ups and downs. That means sometimes it is higher, sometimes lower. That means it also have a pattern, and they are not increasing or decreasing. They are going in a very smoother direction on an average. So in one hand, that is not changing for a long time, and another hand, we can get much more information that can be used for weather prediction. So it has some importance very nicely. This is North Atlantic Oscillation, and then we are going to again discuss about another one. We should El Nino or Southern Oscillation. So Southern Oscillation, which is N means as ENSO. ENSO means Southern Oscillation, and El Nina, EN means El Nina. So the phases, normally these incidents happen in Pacific Ocean, the most deepest ocean, and large ocean also. And these deepest ocean, they have in one side, they have by the side of the Asian, East Asia, that means in Indonesia and China, and later part Japan, and downward it is Australia. So mostly if you see the tropical belt, that includes Indonesia and couple of countries. On the eastern side, they have included the Mexico, and then directly Ecuador and Peru, in those area in the eastern side. So what happened? Normally the ocean, they have in the middle of the ocean, they get interrupted. They get heated up by the sunshine, because of the mid latitude. They get always they get sunlight quite good enough, and they become very lighter, and they take the warm and humid air, and with that humid air they pick up in the top, and all the way around with the circulation of the wind, they come from the west coast to east coast. That means this particular time they get in, they take the enough moisture, and this moisture, it has been gone through all the way to the other side, and in here they get much of the precipitation. That means Ecuador, Peru, and by the side of the Mexico, in that particular time period of couple of years, they get good amount of the heat, and with that heat and precipitation, many things has been significantly impacted in their life. For example, they get flooded, and there much of the rainfall created much of the agricultural production, and also with the warm temperature, they also have a good amount of the fish catching of the fish. And then on the other hand, in the other period, which is described as La Nina, that time this sail has been disrupted. Sorry, I should have to say this circle we can say also Walker cell, and that has been disrupted in the La Nina, because at that time the surface temperature is not very hot, and in eastern pattern, and all the way along they come to the western side, that means Indonesia and Australia and this side. So at that time, in this particular area, they have also good amount of the rainfall, but in the other side, that is full of dry and cold. And we do know that is an upwelling of the cold water in the downward, that moves in that direction, and the top way, when they get evaporated and warm things, they all the way they circulated in the right way. Protoy, do you want to say something? Protoy? You raised your hand. Do you want to say something or you wanted to write it down? Yes, thank you. What is La Nina? Okay, thank you. I'm describing that. La Nina is the opposite phase of the El Nino. El Nino means when that particular warmer part of the water bodies that has been evaporated with warm water and evaporation, and all the way these warm clouds, they move with the wind to the opposite direction, they get settle down in here. So you see this red color in here, they have been also hot and humid, and that time the precipitation happened. On the other hand, the other phase, La Nina, the opposite phase of that one, that triggers that the surface ocean is not heated enough, and that heat cannot be in a circular way. They has been interrupted in here, and the other part of the eastern side, they are very much cold, and they don't have enough warmness and moistness. They lose that, so they are much more dry in that particular time. They do not have much of the fishing, much of the agricultural production in here. So this is the opposite condition of both of them. And why this is happening, we don't know actually, because the scientists are still saying that this is a circular oscillation. Oscillation means which goes in one direction and come back to another direction and again go to another direction, like they are in a circular pattern, they are going through. So this is also a variability, and this can also be dependent on internal mechanism. Let's see some videos on southern oscillation so that we can understand more nicely about that.
ENSO. If you break it, EN stands for El Nino and SO stands for Southern Oscillation. Because ENSO phenomena mostly occurs at the southern hemisphere, just right below the equator. And when you look at the term oscillation, it gives us a hint that something oscillates from one place to another or back and forth. If you want, you can pause the video and think about what could be that thing. Well, it's the temperature that we are talking about. And not just any temperature, ocean temperature. It is the ocean temperature that oscillates back and forth from warm temperature to cold temperature and vice versa. Now, the next question that should be in your mind is, which ocean are we talking about? I'll give you a hint. It's the largest one, Pacific Ocean. You see, Pacific Ocean is this large pool of water that exists on the western side of the American continent and eastern side of the Asian and Australian continent. This large pool of water gets intensely warm due to the fact that it exists right at the equator. And we all know that the equatorial region receives great amount of sun rays all throughout the year. So far, we have learned what and where ENSO takes place. Now it's time to know how it all happens. To understand how ENSO occurs, we will need to break it into 3 phases. That's how it will make sense, and step by step the concept will get clearer. The first phase is neutral phase. Actually, there is no such thing as a neutral phase when it comes to any of nature's phenomena. You see, nature has a constant ongoing cycle that has never stopped. But for our own understanding, we will have to create a neutral state where we can see how a particular thing starts and goes on. So the first phase among the 3 phases is the neutral phase. In this phase, the central Pacific Ocean is warm. Now let's bring in the trade winds. Trade winds are these wind that blows in the tropical region from eastern side to the western side. They are also known as tropical easterlies. So as we know that the equator receives great amount of sun rays, and that's what warms the Pacific Ocean. The trade winds pushes the warm ocean current towards the Asian side, because trade winds blow from east to west, and that makes the western Pacific Ocean warm. You know, the region around New Zealand, Australia, and Indonesia. This region is called the Western Pacific Pool. Here the ocean temperature is warm. The warm ocean current affects the surrounding atmosphere by increasing the temperature as well as the moisture content. And we know that warm air rises high into the atmosphere. It is through the convection process, and that's how clouds are formed, and then it rains. The warm air then travels east towards Eastern Pacific Ocean. You know, the region near South America, especially countries like Ecuador and Peru. The warmer air, when it goes up, it reaches the end of troposphere. And if you know, the top of the troposphere is cold. When warm air meets cool air, slowly it loses its moisture content and the air becomes dry. The dry air travels towards the eastern Pacific side and comes down over the Peruvian coastal region, making the region cold. This pattern of rising air in the west and falling in the east continues, and it is known as Walker circulation. So this was the neutral phase. I hope you understood this cycle. It's plain and simple. Now comes the second phase. It's called El Nino. So in the neutral phase, we saw that the trade winds played an important role in pushing the warm ocean current towards the western Pacific. Now in this phase, the trade winds are weak. Yes, there are few months in a year when the trade winds are weak. When the trade winds are weak, the warm ocean current do not get any kind of push. So what happens is the warm pool of ocean water at the western Pacific slowly moves towards the central and eastern side of the Pacific Ocean. So this is where the oscillation term comes in. You see the warm ocean current is replacing the cold ocean current that exists in the central and eastern Pacific. When I say replace, what I mean is that the cold water is dense and it settles down in deep ocean, and warm water goes up and takes over the surface of the ocean. Okay, I hope you're understanding. When this warm ocean current moves, everything that is associated with it, like the convection process, then the formation of rain cloud, everything moves along with this warm ocean current. What you will notice now is that the Walker circulation that we saw in the neutral phase, that one big looping pattern, it's now breaking into two parts. Just look at this loop. As a result, the ocean temperature near Australia is cool and there is no rain, though the inland parts of Australia witnesses severe drought condition. But on the other hand, near the Peruvian coast, the warm pool of ocean current brings heavy rain, flood to the American continent. So whenever you hear the word El Nino, immediately think of warm ocean current. And the third phase is La Nina. This is similar to the neutral phase. In this phase, the trade winds are strong. Since trade winds blow from east to west, hence it pushes the warm ocean current from the eastern Pacific towards the western Pacific. Now imagine this. Cold water is dense and it settles down in deep ocean. So that means the temperature of the ocean surface is warm. Now, if the trade wind pushes the warm surface ocean current towards the western Pacific, the cold water from the deep ocean immediately comes up at the surface. There's a word given to it. It's called thermocline. Thermocline is the rising path of water temperature. And the rest of the process is same. We saw that in the neutral phase. Western Pacific region of Australia, Indonesia, New Zealand gets heavy rain storm. The effect of La Nina is more on these countries than El Nino. So El Nino is a warm ocean current and La Nina is a cold ocean current. Remember that.
So this is all about the ENSO. There are many other videos. You can also see many of them. But the basic thing is these are a couple of internal mechanisms that we need to discuss about and we need to understand so that the internal mechanism can be discussed. So so we have many others also. We have also multi-decadal oscillation. We're gonna discuss in the next class. But up to this, do you have any question regarding ENSO and Atlantic oscillation? Do you have any question? Can you understand it? Because it is very important. In your exam, it might become that how the North Atlantic oscillation have some impact on the weather pattern of UK, or what is the result of the El Nino on east and western side of the Pacific Ocean. So can you describe that?
Yes, sir.
Okay. Okay, so maybe I should stop here, and in the next class, we're gonna discuss about rest of them. I need another class in the next week. So in the next week, as 14th and 16th are government holidays, so I will take the class on Sunday and Tuesday in the same time. Okay. Someone, sir, can you explain La Nina part again? Okay. Let's see about what does it mean. See this one, La Nina means La Nina, that means that which is opposite of the El Nino. El Nino means when the temperature increases, when the trade winds, which is coming from right direction to left direction, that means from the eastern side of the Pacific, they come to all along to the western Pacific. And when they come through all the way, that time the trade winds is become very weaker in the El Nino phase, but in the La Nina phase it is very strong. And then when it comes from all along this path, so all the surface water which is warm enough, they come to the western part, that means from by the side of the Indonesia and by the side of the Australia. And when it is very warm and humid, that times they get evaporated here and they get much of the precipitation in here because of the strong trade winds. Okay, and then as it is very hot and humid, that means under the ocean, normally the cold water which is very wetty, they are in the bottom, and they wanted to, when it is very hot, that upwelling water, that they tend to come to in the opposite direction. And as the cell has been interrupted in here and maximum precipitation happen in here, in that time the eastern part of the Pacific Ocean, they become very dry and they become very cold. So this is the phase of the La Nina. Another one, sorry sir, it was mistakenly sent. Oh, it's okay. So can you understand, Shubro, what I mean, that El Nina is the phases where you get the maximum amount of the rainfall in the right coast, and on the other hand La Nina in the left coast. Okay, thank you. Is there any other question? Do you have? No. So
No, sir.
yeah, okay, so Siam, I will take the next class on 13th, Sunday, same
Yes, sir.
time. Okay,
Yes, sir.
maybe in the next week I'm going to finish your courses, because I need another class for this one, and maybe the last chapter I need only only 2 classes at a time. So maybe next week is the I will completed your course. So thank you joining me, and hopefully we'll come back in the next week.
Assalamu alaikum.